Let's look at an example of the binomial distribution. The binomial distribution determines the probability of a certain number of successes in a given number of trials. So in this particular problem, we're looking at 20% of students have taken an art class at BCC, random sample of 5 students is taken. What is the probability that exactly 3 have taken an art class at BCC? So I'm looking at a particular value, and I'm trying to find the probability that X is equal to 3 successes if this is out of 5 trials and my probability of success is 20%. I'm going to show you how to do this using technology, starting with the TI-84 calculator. The 83 works pretty similar. I'll explain a slight difference between the two. To find binomials, I hit the second button and then the vars. And then I choose the option, so I'm going to scroll down until I see binomial PDF. I'm using PDF when I'm looking at a single value like equals 3. I use CDF when I'm looking at less than or equal to some number of successes, so less than or equal to 3, for example. So in the 83, it won't have this interface that you type in your values, so you're going to have to type that in by hand. I'll show you the setup, but the general idea would be the same. Number of trials, well, this is out of 5 samples. My probability of success is 20%, and my X value that I want is 3. So I'm going to hit paste, I'll hit enter, and it gives me my probability. So when I do BinomialPDF 5, 0.2, and 3, this gives me the probability of 5.12% or so. So what this looks like on a TI-83 is it's going to have this line here, but it won't have everything filled in for you. So let me just delete a couple things. So it's going to look like this on the 83. So you're going to want to type in the number 5, and then comma for the probability, 0.2, comma, so you can type in that X value, and then close the parenthesis. The comma button's above the 7, so you're just typing in the N, the P, and then the K. So it works very similar on both calculators. It will give you the same answer either way. Let's look at how to do this now using a TI-89. And if you're doing this inside of a TI-89, you're going to need StatList Editor. So you're going to go into Apps, and then choose the app for StatList Editor. Enter to go in. I'm working with distribution, so I'm up top here, and I'm going to select F5. And I'm going to scroll down until I see something for binomial PDF. There we are. Number of trials, well, this was out of 5 trials. There was a 0.2 or 20% success rate. And I wanted 3 successes out of the 5 trials. So when I hit enter, and then enter again, it gives me the probability right here, 0.0512. Looks like it's matching up just fine. Again, my process for the 83 and 84 is second, vars, and then BinomialPDF. For the TI-89, it's StatList Editor, F5 for distribution, and then BinomialPDF. Let me show you how to do this now in GeoGebra. So in GeoGebra, I go into the option for probability. So when you open it up, it'll look something like this. I'm going to choose this option for probability. In the drop-down menu, I'm going to select the option for binomial. And then I'm going to type in my number of trials. This is out of 5 trials. I'm going to type in my success rate. Success rate was 20%. and I wanted equal to 3. So all of these numbers on the side, these are my probabilities. So for example, this right here is my probability that x is equal to 3.0512. My numbers are matching up just fine for the 83, 84, 89, and GeoGebra. Finally, you might be in the case where you have an instructor that's expecting you to do this by hand. So let me show you what that formula and process looks like. The probability that you have k successes and n trials is out of n places you're choosing k successes. For the number of probabilities for success, you want k of them. And for the number of failures, you want the remaining n minus k. And this is sometimes written as n factorial over k factorial n minus k factorial. And if this is something you've never seen before, feel free to just sort of skip this and stick to the technology. I'm only showing this to you in case you wanted to do the thing by hand. I'm going to fill in my numbers and explain really what's going on with the setup. I find that it's much nicer to comprehend this thing once you actually have the numbers in. So here I'm looking at 3 successes. So I'm going to have 5 factorial over 3 factorial and 2 factorial. So this is really what I've got going on. On the top, I have the number of trials, and on the bottom, this is the number of successes and the number of failures. So this total thing is going to give me the total number of combinations of 3 successes and 2 failures. Now I need to know the probability of each of those combinations, and I had a 20% success rate, and I wanted 3 successes. Likewise, then for failures, if I have a 20% success rate, then that must mean I have an 80% failure rate. And if this is out of 5 trials and I have 3 successes, then I'm going to have 2 failures. So ultimately, this is using the multiplication rule to come up with these probabilities. I'm multiplying 3 successes, 2 failures, and I'm accounting for the total number of combinations, because I could have something like 3 successes as the first 3 trials and then 2 failures. Maybe my 3 successes are the last 3, or maybe my 3 successes are sort of spread throughout the 5 options. So this counts everything that can happen. Now here's how these factorials work. This means 5 times 4 times 3 times 2 times 1. 3 factorial, it's everything 3 and less that gets multiplied together. 2 factorial, that's everything 2 and less that gets multiplied together. So these exclamation marks, these mean multiply that number and lower. 0.2 cubed and 0.8 squared. I can already do that in the calculator, so I'm not worried about that. Let's see if I can simplify this at all. I'm noticing that I have 3's on the top and bottom I can cancel, 2's, and 1's don't really change anything. So I'm left with 5 times 4, or 20. And on the bottom I have 2. 20 divided by 2 means there's going to be 10 unique combinations with 3 successes and 2 failures. You can try to list those out letter-wise. So you have 5 spaces and you need 3 S's and 2 F's. If you mix those up, you should be able to come up with 10 different values. So I wanted 3 successes and 2 failures. I'm going to type this into a calculator now. I've got 10.20 to the third, 0.80 squared. And when I type this in, it gives me 0.0512. So it's giving me exactly the same thing, but it certainly takes a lot longer than using technology. If this is something that you enjoy doing, continue to do it that way. If you prefer using GeoGebra, use GeoGebra. But you also have the TI-83, 84, and 89 calculator to give you lots of options for how to approach this.